Okay, so now let's look at some different problem. So this is find the volume of solid generated by revolving the sheet region about the given axis. Okay, so first problem is this is the region. This is y equals 4. This is y equals square root of 4x. That's the region, right? So I'm going to start to do the rotating here about the y-axis. So basically, it's going to have something like this. Okay. So clearly, we can use the washer to deal with it, and then the radius in terms of y, because we're doing the integration with respect to y. Okay, it's gonna be, you need to solve x in terms of y. So this is y equals square root of 4x. So y squared equals 4x, and then x equals y squared over 4. So that's the radius, y squared over 4. So once we drive that, we can set up our volume integral. So from 0 to 4, right? Pi times the iy squared, which is y squared over 4, then squared dy. So now you have is pi over 16 y to the power 4th, 0 to 4 dy, right? So we can factor this out. So y fifth over 5 from 0 to 4. And then we can plug in, so it's pi over 16 times 4 to the power 5th over 5. So if you simplify, this is going to become into 64 pi over 5. Okay, so let's try to see if we get something. 64 over 5. Okay, so there we go. Now number 11. So this one is we're looking for something about the x-axis. So we can still using the washer, right? And in fact, the washer in terms of the radius, which is exactly the r. So r of x, the radius is negative 5x plus 10, right? And it's from 0 to 2. So the volume is going to be from 0 to 2 pi times negative 5x plus 10 squared dx. Okay. That's number 11. So if we can solve for this integral, let me write it here. So from 0 to 2 pi, put it here. So 25x squared minus 100x plus 100, right, dx. In fact, we can factor 25 out. So that will give 25 pi 0 to 2 x squared minus 4x plus 4 dx. Okay. So let's see, we got x cubed over 3 minus 2x squared plus 2x, right? Oh, plus 4x, my bad. From 0 to 2. So hence, what do we got? We got 25 pi 8 over 3 minus 2 times 4, right? 2 squared is 4. And then plus 4 times 2. So it turns out those two cancel out. So now we got 25 pi times 8 over 3. This is going to be 200 pi over 3. Let's try to see if we got something. Okay, so the answer is right here. Okay, so that's number 11. Now number 12, located here. Find the volume of the solid generated by revolving the region bounded by the given lines and the curves about the x-axis. Okay. So let's draw that. X equals 0, which is the y-axis. Y equals 3x, which is right here. Okay, this is the y equals 3x. Y equals negative 3x plus 6. It's going to be something like this. Okay, so this is y equals negative 3x plus 6. Okay. And the so the region bounded by this is x equals 0, right? X equals 0. So x equals 0, which is here. So it turns out this is the region. Okay, this is the region. And we're trying to get it, the curve about the x-axis. Okay. So simply speaking, I get something like this, and starting to do the revolving. Okay, starting to do the revolving. So what we can do? Well, I think the first thing what we can do here is we can, first of all, we can use a also use the Washer method. Okay, also using the Washer method, because as you can see that this is the small r, right? This is the small r. And then this, the upper one, is going to be the capital R, right? Because you think about it, if you're trying to do the revolving here, that's something what you get, right? That's something what you get. And then we can do the integration. So first of all, let's find the intersection point here. So this is very important. So that is y equals negative 3x plus 6 and y equals 3x. Okay. So if we solve both, that is negative 3x plus 6 equals 3x. Turns out 6 equals 6x and then x equals 1. So at this point, this is the point 1, comma 3. Okay. So now let me use another paper to give you some more details here. So in other words, guys, this is what we drive. So that's the graph, that's the region. This is y equals negative 3x plus 6. This is y equals 3x. This point is 1, 3, right? So we're going to do the revolving about the x-axis, about x-axis. So what we can do here is we can, using the washer, so the larger radius is negative 3x plus 6. That's the larger radius. Okay. The smaller radius r, which is 3x, okay, which is 3x. So the volume, it's from 0 to 1 pi times capital Rx squared minus pi times small rx squared and then dx. So that is from 0 to 1 pi times negative 3x plus 6 squared minus pi times 3x then squared and then dx here. Okay. So what we can get? Well, we can factor pi out. And then it's gonna become into a difference of squares formula, right? That is a squared minus b squared is a minus b times a plus b, right? So a minus b is going to be negative 3x plus 6 minus 3x. A plus b is going to be negative 3x plus 6 plus 3x, and then dx. So now you can see that negative 3x and 3x cross out. Okay, so now what do we get? We got 6 minus 6x times 6 dx. Okay, so we can even factor this 6 out. So give us is 6 and then times 6, so 36 pi 0 to 1, 1 minus x dx. Okay, so now do you realize that this integral is super easy to evaluate? So let's put it here. So 36 pi times x minus x squared over 2 evaluated from 0 to 1. Okay, so now, so 36 pi times 1 minus half, this is half, so we got 18 pi. Okay, so that's the answer. So let's try to see if we got it correct. Do we have 18 pi? Well, the answer is yes, sir. We got 18 pi. Okay, so that's what do we got so far.